again, this is the Math Dog. In this video, I'm looking at composite translations of linear functions part 2. These are practice questions. So before you even attempt this video, you should have watched my video on composite translations of linear functions part 1, where I go through the nitty-gritty details of why composite translations are formed the way they are. In this video, I'm going to do less of the theory and more of the practice here. So to do this video, you should have pencil, graph paper, and a ruler ready to work the practice problems. Okay, well, let's begin. Okay, so reviewing, the general form for translating a linear function f of x in a two-dimensional space is f of x equals a times quantity x minus h plus k, where a is the slope. Sometimes it's called a dilation, shrink, or stretch, but we're just going to call it slope here, especially for a linear function. Okay, that's going to be your slope. So in a nonlinear function like a quadratic, it would be the stretch or shrink. H is the horizontal shift, so x minus h. If h is positive, that's going to be like x minus 3. That would be a shift actually right. If h is less than 0, so let's say h is negative 5, that'd be x minus 5, which is x plus 5. That would be a shift to the left horizontally. It's either right horizontal or left horizontal. And then k is my vertical shift. That's up or down. So if k is greater than 0, it's going to be a shift up. If k is less than 0, it's going to be a shift down. Alright, let's do our first practice here. Given the function f of x equals 2x, translate the function 6 units left and 5 units down. Call the new function g of x. So if you can do this without filling some of this out, that's okay. But I would like you to write g of x in 3 different ways. 2 ways using the function f, and the other way where you're just using x. Alright, so now you can stop the video, and when you're done, see if you agree with what I got. Alright, so again, I'm using what I covered in the first video, part 1. So I could write g of x here is, and let's note here that this is a shift starting here at the old origin. That's a shift 6 left and 5 units down. Okay, so I could write this in terms of f by writing this is f of x plus 6, because I'm going 6 left, so it's x plus 6 as I've discussed in many previous problems, and then I'm going down 5. So this is one way to write the function. Okay, second way is note that f of x is 2x. Therefore, f of x plus 6 is 2 times quantity x plus 6. So I could write now g of x equals, replace f of x plus 6 with 2 quantity x plus 6, and then I have minus 5. Okay, so now let's multiply that out. So that's 2x plus 12 using your distributor property minus 5. So g of x is 2x plus 7. Okay, and let's verify. The first one is 6 left, 5 down. The second one says 2x plus 7. So let's just take this point right here on f of x. 1, 2, 3, 4, 5, 6, 7. So that's correct. Notice though that 2x is also f of x. So this is a second way, and a third way is I could write this as g of x equals f of x plus 7. Okay, so those are 3 ways. So again, if you're filling out the table, here are the graph, the missing values here. That's going to be 0, 0. I changed the new origin. This in terms of the old coordinate system, this new point here where I'm translating my axes to is going to be negative 6, negative 5. And in the new coordinate system, that's 0, 0. So we would get capital X is equal to little x plus 6, because to go from -6 to 0 I have to add 6, and then y, capital Y, is going to be, and going from -5 to 0 has to be little y plus 5. So using this method, again, big Y is going to be 2x, because it's the identical function as this, except we're starting from here. It has a slope of 2 also. Both these have a slope of 2. Okay, you can see that. The rise to run is 2 to 1. We're changing Y, we're changing X. Well, Y here from the table is Y plus 5, and that's 2. Replace big X with little x, we get this. Okay, so this is Y equals 2 quantity x plus 6 minus 5. Okay, but again, f of x is equal to 2x, so f of x plus 6 is equal to 2x plus 6, so let's call y now g of x. This is equivalent to f of x plus 6 minus 5, and then from this point, just what we got here, we could then derive these other two. Alright, let's move to the next practice problem. So given the function f of x equals 3x plus 2, which I've already graphed for you here, translate the function 5 units left and 4 units up. So we're going to go 5 units left, 4 units up, call the new function g of x. So I am starting from the old origin. I'm going 5 units to the left, right here, then I'm going 1, 2, 3, 4 units up to give me the new axes here. Okay, so stop the video and see if you can write g of x in 3 different ways, and then complete the table. The blanks I have here, I have a couple blanks here, here, and here. I guess if I didn't mention, I have from here as well. Okay, so stop the video and try to write g of x 3 different ways. 2 of the ways should involve f, the function f, and the other way is just in terms of x. Alright, so I am moving left here 5 units, so I'm going to write g of x. I'm shifting f. I'm shifting the function 5 units left, so that's going to be f of x plus h and 4 units up. So that h should be 4 here. I'm sorry, should be 5. So we get g of x equals f of x plus 5 plus 4. Now, again, note that f of x, in this case, is 3x plus 2. So f of x plus 5, everywhere is an x here, I replace it with x plus 5, so I have 3 quantity x plus 5 plus 2. Okay, so now I can replace f of x plus 5 in this g of x with this. So now I have g of x equals, so let's circle this. This is one way to write it. So g of x is going to be 3 quantity x plus 5, I'm sorry, 3 times quantity x plus 5 plus 2. Well, g of x is 3x plus 15 plus 2. So another way is g of x is 3x plus 17. Okay, that's in terms of x. Now, we could do this as well. We could go, okay, the function is 3x plus 2. So f of x is 3x plus 2. So I could rewrite this here as 3x plus 2 plus 15. Okay, so that gives me, this is just f of x. So we could write this as g of x is f of x plus 15. So here are 3 ways to write g of x. this way, this way, and this way. So if you're filling out your table here, I'm just going to do it for good measure. The original origin here is going to be 0, 0. My y-intercept of the original function is 2, so that's 0, 2. X is 0, y is 2. And then this is the new translated axes in terms of the old coordinates. That's going to be negative 5, 4. In terms of the new coordinates, that's going to be 0, 0. Okay, this is the function capital Y equals 3x plus 2. This is in a new coordinate system. This is also going to be, this is the y-intercept of 2, so that's 0, 2. In the old coordinate system, that's going to be again 5 left, but instead of being 4 up, we're going to go 2 more up, so that's 6 up. Alright, so let's write using this. Let's show that we can get this. Alright, so we know that x, big X, is going to be, to get from negative 5 to 0, I have to add 5 to little x, and to get big Y, I have to subtract, to go from 4 to 0, I have to subtract from, that should be little y, not little x. So I have to subtract 4 from little y. So we get, then, in terms of y and x, we have y equals, this is going to be 3 big X plus 2. So y is going to be, let's change color here. I'm going to go down here now. So big Y is 3 times, replace big X with little x, plus 5. And then this is going to be plus 2. Now I should have replaced big Y with little y minus 4 right here. So now I can write y equals 3 quantity x plus 5 plus 6. Okay, but we know that f of x is defined here as 3x plus 2. Therefore, f of x plus 5 is equal to 3, replace x with quantity x plus 5 plus 2. Okay, so that means, and actually let's remove this step, and before we go to the last step here, let's actually, this is going to be, notice this is just f of x plus 5, so this is going to be y minus 4, little y minus 4 equals f of x plus 5 plus 2. Okay, actually it's not plus 2, because f of x plus 5 is 3x plus 5 plus 2, so I can replace this entire expression with this. My last step is I add 4 to both sides, so I get y is f of x plus 5 plus 4. And then, of course, y is also g of x. So I get that, which, if we go back up to the top, that is what we got originally. So then, from this you can derive, using what I did over here, you can derive the other two forms. So you have two forms in where g of x is in terms of f, and the other one where it's in terms of x only. Alright, without a piece of graph paper and ruler, translate the function f of x equals 3x minus 1, 10 units to right and 3x, 7 units down. Call the translated function g of x. So hopefully we can do this now without graph paper. Alright, stop the video, see what you can do with this. Okay, let's go over the solution here. We're going to write the function 3 ways again, so I'm going to start with, so I've got my function f of x equals 3x minus 1. I'm going 10 units to the right and 7 units down. Okay, so g of x is going to equal f of x minus 10, because that's going to shift 10 units to the right, and then I'm going to go 7 units down. So we have that. Okay, so that's one way of using f. Now another way is g of x is equal to, well, what's f of x minus 10? Well, f of x is 3x minus 1. So f of x minus 10 has to equal 3, replacing x with x minus 10. Minus 1 gives me 3x minus 30 minus 1. So that's going to be 3x minus 31. So g of x could also be written as 3x minus 31, where negative 31 is my y-intercept. Now, taking this, I could then note that f of x is equal to 3x minus 1, so I could rewrite this as 3x minus 1 minus 30, and this is equal to f of x. So a third way of writing g of x in terms of f of x is replace 3x minus 1 with f of x, so this would be g of x is f of x minus 30. Okay? Alright, so let's move on. Alright, we're finally at our last question here. So when I'm done talking, stop the video and see if you can again write this function 3 different ways. So write the function g of x in terms of translation of the function f of x, and notice the original function f of x has a slope of 2 or 2 to 1. And also, just a hint here, use a horizontal translation from here to here to get yourself started. Okay, stop the video. See if you can write the function 3 different ways. 2 ways g in terms of f, and the other way in terms of x. Okay, let's see what we did here. So notice I'm going to do a horizontal translation from here to here, and I will label, this is going to be, I'm not going to call this my origin this time, I'm going to call my origin here 0, 0. Okay, and that's the old. In terms of the old, this is going to be 1, 2, 3, 4, 5, 6, 7 units left, so that's negative 7, 0, and in the new system, that's going to be 0, 0. So without using this first, I know I'm going 7 units to the left, so I could write this function as, let's get the right pen here, I could write f of x, I'm sorry, g of x in terms of f of x. G of x is equal to f of x plus 7, because that's a shift of 7 left. And there is no vertical shift the way I'm doing this. So that's the function right there. G of x equals f of x plus 7. That's one way. Now f of x here in this problem is equal to, in terms of the original origin, is 2x. Okay. So in terms of the new origin, this is going to be, this has a slope of 2 also, 2 to 1. This has a slope of 2 to 1. This is going to be capital Y equals 2x. Okay, so back to this. Let's look at what f of x is. F of x is going to be 2x here in terms of the original function. So that means f of x plus 7 has to equal 2 times quantity x plus 7, because everywhere there's an x, I'm replacing with x plus 7 when I do this. So now another way to write this function would be g of x equals 2 quantity x plus 7. So g of x in terms of x will be 2x plus 14. which means from right here you would shift it up 14 units, which is off my grid. Okay, notice though that f of x is 2x right here, so I can replace this also with I can write this as g of x equals, instead of 2x I put f of x plus 14. So those are three ways to write that function. Now in terms of the coordinate shift, we can write that we know that y, bring this down here, you know that capital Y is 2 capital X. Okay, so we also know that big Y is the same as little y, and to go from old x to new x, or from little x to big X, I have to add 7, because -7 plus 7 is 0. So now we have, substituting into this, we have little y equals 2 quantity x plus 7. So y is equal to 2x plus 14. Okay, but y is also g of x here, so we have g of x is 2x plus 14. So that's one of our ways. Now we remember that f of x, f of little x is 2 times little x, so I could replace this with f of x. So a second way to write this is g of x equals f of x plus 14. Okay. Finally, let's go back to here. So I can say that g of x, let's take this now, g of x is 2 quantity x plus 7. But since f of x is equal to 2x, and this should be g of x is 2 quantity x plus 7, not x plus 7. Since f of x is 2x, that means f of 2x, f of 2 times quantity x plus 7 this has to equal 2 times quantity x plus 7, because all I'm doing is replacing x with x plus 7. Okay, so now since we have this, I can replace 2 quantity x plus 7 with f of x plus 7. So g of x is also equal to f of x plus 7, which again, this means a translation of f 7 units to the left. We did all this up here, but I'm just showing using the translation method that I showed in part 1. This is the y of how this stuff works. So we have this way in terms of x, we have this way in terms of f of x, and we have this way in terms of f of x. Okay, and this concludes the video on composite translations of linear functions.